Hello guys, welcome back to the channel. This is second part of Cambridge IGCSE paper 4. So in the first video we did question 1 to 13. Here we are going to do other remaining question. So let's start. The question that we have here is from linear programming. You can see some lines here and the shaded part. The question is find 3 inequalities that define the unshaded region R. So this is the unshaded region here R, which is shown here. So we will find out the inequality. So first of all, if we see this line here, I will see this line is here x equals to minus 4, right? X equals to minus 4, but you see the unwanted shaded is region is shaded. So right hand side this is greater than x, this will be x greater than or equals to negative 4. So one inequality is x greater than or equals to minus negative 4. Another one, the straight line, we have this line here. So we have this dotted line. First of all, let's see this line, slanting line here. So I will take here, you know that the equation standard form of the straight line is y equals to mx plus c, where m is this gradient. So if we are talking about this line, you can choose any point. So I'm choosing this point here. You see this is 4 and this is 2. So 1, 2, 3 and 4. So gradient is m, that is change in y over change in x. Change in y is here 1 and 2. So this is going to be 2 over 4. As you can see, line is going downward. So line is going downward, so that means this gradient is negative. So this is negative half. So m is a negative half here. So line is negative half and y intercept is c. It is intersecting y at this point 2. So c is 2. So equation of the line is y equals to negative half x plus 2, but this line is bold, so there will be equal sign also, and this line actually, you see all the points are down here to this line. So y is going to be less than or equals to negative half x plus 2. Okay, so we can also rearrange it to make it look nice. If you multiply throughout by equation by 2, it will be like this, and I can also write down 2y plus x is less than or equals to 2. So this is how we can represent here. I can write it down, x plus 2y is less than or equals to, sorry, when you multiply here by 2, this will become 4 is less than or equals to 4, right? Now the next one here, the dotted one, this line here, this is going upward. You see this is going upward, so slope is going to be positive. So for this one, we will have y is equal to mx plus c. So c, it is intersecting, the y intercept here is at 1, it is intersecting at 1 over here, so plus 1 mx. So let's see what is the gradient. The gradient is, if I choose this point here, let me just change the color. So for the gradient, if I choose this point here, you see, you can, let's take this point, going 1 across, and this is 2. So m is y over sorry, I think I'm taking it, wait. So let's choose another point from here. You can choose any point. So from here to here. Okay, yeah, this was actually not correct. So y, change in y is this line here, 1 over 2. Oh, sorry, I'm just taking long line here. We were doing this line here. So here is like, if I'm taking this one, let's say I'm taking this point going down, y is 1 and 1. So 1 across 1. So gradient is 1 over 1, that is 1. Okay, so that means equation of the line y is equal to m is now 1 x plus 1. So this is y equals to x plus 1. So now the points are above there which are shaded, so region is down there. So this is going to be let's say we have this point here. This point's coordinate is -2 and x -2 and y is 2. You can see y coordinate is greater than this one, x coordinate. So this is going to be y greater than x plus 1. So that's the equation, y equals to x plus 1. Done. So now next question, we have the question from functions here. So we are given fx and gx. Find g of -8. So we are just going to replace here x by -8. So this is going to be 7 plus 2 into -8. So this is 7 minus 16. So it is -9. So -9 is answer. Now g of f5, g of f5. So for f5, first we have to find out f5. So f5, just replacing the values of here in fx as 5. So 2 instead of x, now we are writing 5. 5 squared minus 3 into 5. So 3 times 3, 9, times 2, it is 18. I'm sorry, this is not 3, this is 5. 5 squared 25 times 2, it's 50, minus 15, that is 35. So f5 is 35. So I'll replace this f5 by 35. So now g35. So g35, 7 plus 2 into 35. So 7 plus 70, that is 77. Right. Now g inverse x. Now we have gx here. First of all, we will take gx is 7 plus 2y. 2x. So gx will be replaced by y like this. Then make x the subject, 2x over 2 over 2. So we got x equals to y minus 7 over 2. So that means g inverse x is x minus 7 over 2. Right. Now part B, find x minus 6, give your answer in x squared plus bx plus c form. So f of x minus 6, f of x minus 6. So let me first write down fx here. Fx is 2x squared minus 3x. 2x squared minus 3x. And we are looking for f of x minus 6. So just plug in x as x minus 6. Now just simplify, expanding the brackets, right? So once you expand, this is 2 into a minus b whole square. You know that a minus b whole square formula is a squared minus 2ab plus b squared. We are going to use this one. So this is x squared minus 12x plus 36. Then minus, expand this one, 3x plus 6. So this is now expanding this bracket, 2x squared minus 12 times 2, 24x plus 72 minus 3x plus 6. So it is 2x squared. So 24 minus 3, both are negative, 27x plus 72 plus I think I missed this one, 3 times 6, it should be 18 here. This one is not 6, this is going to be 18. So 72 plus 18, it is 90, right? So we got the answer, which is of the form ax squared plus bx plus c, right? So this is going to be 2x squared minus 27x plus 90, right? Now part C, use the quadratic formula to solve fx minus 6 equals to 0. So fx minus 6. Now fx, again fx is 2x squared minus 3x, right? So that means we are looking for fx minus 6 equals to 0. So fx is 2x squared minus 3x minus 6 equals to 0. So for using the quadratic formula is negative b plus minus b squared minus 4ac over 2a. So minus 3 plus minus negative 3 squared minus 4 times 2 minus 6. So you all know how to use the quadratic formula. It's not that's not a big deal. So here we have 3 plus minus 9 plus 6, 4 times 2 8 times 6 48 over, you can directly use your calculator also, because this paper you can use calculator. So from here we are getting the values of x as negative 1.14 and 2.64. so minus 1.14. remember to write your answers in the space provided to you. Okay, now number 16, we have this table here. The Tina records the mass of each of 120 apples. You can see mass, and then we have frequency. Calculate an estimate of the mean of the masses of the apples, right? So first of all we need to find out the midpoint here. So midpoint 150 plus 180 divided by 2, 165. Similarly here 180 plus 220, and adding these two divided by 2 we got 200. Then we got 245 here and 285, right? So mean is going to be 165 times 18 plus, so you're just going to multiply these two columns here. So then 200 times 28, 245 times 65 plus 285 times 9 divided by the total number of apples, so which is 120. So just plug in the values, calculate, and you got 225.5. Draw the histogram to show the information in the table. So for histogram we need the frequency density. Now the formula of frequency density is equal to frequency over the class width. So now frequency, first in the first table we have frequency is 18 and the class width, if you see, is 30. 150 to 180 it is 30. So this is going to be 18 over 30. When you calculate, this comes out to be 0.6. And the second one here we have 28 divided by 180 to 220, it is 40, 28 over 40. So going the same way, 28 over 40, this comes out to be 0.7. Then the other one is 65 over 50, I have already calculated, 1.3. Then we have 9 over 30, which is 0.3. Now we will plot all these on the frequency diagram. So first class width is we have here 150 to 180. 150 to 180 is up to here, okay, and this is 0.6. So 0.6 is here. So we will draw the line. Like this, right? Second one is 0.7 and second class interval is 180 to 220. 180 to 220 is here, and this is 0.7. 0.7 is in the middle somewhere here. Use your ruler to draw these lines carefully, right? So this is 0.6, this is 0.7, right? Then 1.3. 1.3 is for this class interval 220 to 270. 220 to 270, it is up to here. 1.3. 1.3. 1 is here, 1.2, 1.3 is in the middle somewhere here. 1.3. Lastly we have 0.3. 0.3 is for 270 to 300. It is 0.3. 0.3 is in the middle of 0.2 and 0.4, right? So that's how you will complete this frequency and the histogram by using frequency density, right? I hope you guys are getting everything. Kindly subscribe to the channel if you are new to the channel, and share it with your friends, and also write in the comment section about your feedback, please. Okay, part C, one of the 120 apples picked at random, find the probability that this apple has 180 grams or less. So 120 apples picked at random, one of the 120. So we are looking a mass of 120 grams of less, 180 or less, 180 or less. Let's go back here. 180 or less is down here. You see this one, 18. So it is 18 over 120. You can simplify, or you can even leave it here. Now this one is a bit tricky. Two apples are picked at random from those who with the mass of greater than 180. Now greater than 180, find the probability that one of these apples has mass greater than 270 and the other apple has mass of 220 grams of less or less. So we have two conditions here actually. So one is this one here, greater than 270, another one is less than 220, right? So greater than, first of all we will go for this greater than 180. Greater than 180 is all these 28, 65 and 9. So we are looking for this total 28, 65 and 9. So this total is going to be, from here it is going to be 28 plus 65 plus 9, this is 102, right? So now the probability of these masses, so if they are taking first of all greater than 270 and less than 220, greater than 270 and less than this one. So we are talking about now this we have 9 out of, so it will be 9 out of 102. And the second one, when we choose, this is mass less than 220 grams of less. So total, when we take the next time, the total is going to be one less than that. So 220 grams or less, 220 or less is here, 220 or less here, this is 28. We are already taking greater than 180 and less than now 220, so it is only 28. So this is going to be 28. So this is one probability. It can be like the other way also. It can be also like first one 28 over, then second one we picked it. So this is going to repeat twice. So this actually is 2 into 9 over 102 times 28 over 101. Once you calculate, this comes out to be 84 over 1717. Okay, so final answer is 84 over 1717, right? Okay, now number 17, we have this diagram here. You can see the diagram shows positions A, B, C, D on a football pitch. Show that angle CAD is 86.2 degree. CAD, we are talking about this angle, right? So this we need to show. So we can, you see we have the side, so we can use cosine rule here. So by cosine rule, you know the cosine rule is, if we have a square, then it is going to be b square plus c square minus 2bc cos of a, right? So then here we have a square. We are talking about a is the opposite side, which is 20. So 20 square is equal to 10 square plus 18 squared minus 2 times 10 times 18 times cos of CAD. We are talking about angle CAD. That's what we are looking for. So from here we will have the cos of angle CAD, that is going to be 20 squared minus 10 squared minus 18 squared over, this is going to be 360, so over 360. So when you calculate, then it comes out to be 18.17, right? So that's the value of angle CAD. Then we have the next angle, obtuse angle ACB. So angle ACB, we are looking for the obtuse angle ACB. For that angle, let me go to there. ACB is this angle here. So now we cannot use the we have this side, this angle we got it 86.17. So now we are looking for this angle. For that we can use sine rule. So by sine rule, we have sine 27 over side opposite to that is AC, which is 18, equals to sine of ACB over 35. So sine of ACB is going to be 35 times sine 27 over 18, right? So then it is going to be 0.8827. So angle ACB is sine inverse of 0.8827, which is equal to 61.96, right? So this is ACB, but we are looking for the obtuse angle. So for the obtuse angle, we will take it out from 180, will be minus 180 minus 61.96. So this comes out to be 118.04. Why we have done this? Because you know that sine theta is equal to sine 180 minus theta, right? We used this formula. So the final answer is 118.04. Okay. Now next one here, part C, a player runs directly from B to D in time, in 5.3 seconds, right? So from B to D, so I will go back to the diagram from B to D. So we are looking for now this line. So we have to have this BD, then this angle here, and then we will find out. The question is to find out the average speed. So for the speed, we need to have distance over time. Time we do have here. Distance we are going to find out. Distance is from B to D, that is we need to find out BD first, right? So for that we can use cosine rule, but to use cosine rule we should have this angle, right? So for this angle can be found out easily. We have just found this angle is 118.04 and this is 86.17. So this is 86.17. Okay, we will use this triangle ABC. So in triangle ABC, we have 118.04 plus 27. This is the angle, and if you subtract it from 180, then it will give us this required angle. So once you do this, we got here is 121.1. So this angle is no. When you do this, let me calculate this one again. Okay, this is 35 actually. This comes out to be 35. So this angle is 35, but we need this total angle, right? For total angle you add 86.17 and 35. 121.2. So 121.2. So our angle is angle 121.2 degrees. This angle is angle BAD. Now we can use the cosine rule. So by cosine rule we will have tan square BD square equals to AB square plus AD squared minus 2AB times BAD into cos of 121.2. So BD we are going to calculate. So this is tan squared 35 squared minus 2 into 10 times 35 and cos of 121.2. So from here when you calculate BD, you have to take the square root of this, plug in all the values directly, then we will get BD as 41.09. So this is the distance, right? So we are looking for the speed. The speed is now distance over time. So distance is 41.09 and time is 5.3 seconds. So we got 7.75 meter per second. This is in meters, guys. 7.75 meter per second, right? Now number 18, f is inversely proportional to the cube of g. So f is inversely proportional to cube of g. So f is going to be k over g square cubed by the constant of proportionality. Now when f is 0.5, g is 3. F is 0.5 and g is 3 cubed. Find the value of f in terms of g. So okay, so this one is the answer here. First of all, sorry, we have to find out the value of k. So this is the equation, and then k is going to be 0.5 times this is 27, which is 13.5. So value of k is 13.5. So f is going to be 13.5 over g cubed. That's the answer. 13.5 over g cubed, right? Part B, g is increased by 100%. Now g is what is g? G is 3, right? G is 3 when it is increased by 100%. So that means g will become 6, right? So 100% means 100 plus 100. It's already 100. We are taking 200% of 3. That means 200 over 100 times 3, which is 6. So that's how we take g as 6. When g is increased by 100%, find the percent change of f. So f previously we had f we had 13.5 over 3 cubed, right? When you calculate, this is 0.5. This is previously, right? Then after the change, then this become a change in g, this will become 6 cubed, right? So this is 13.5 over 216, which is 0.0625. So this is after the change, and we are looking for the percentage change. So first of all, what will be the percentage change is going to be 0.0625 minus 0.5, this 2 minus 1 over starting was 0.5, the original one, and then times 100. So when you calculate, this is negative 87.5, negative 87.5, right? Now number 19, the area of the triangle is 20 meter cubed, correct to nearest square meter, right? So this is nearest square meter. So 1 divided by 2, it will be 0.5. So we are going to add or subtract 0.5 here. The base is of the triangle is 5.7, correct to nearest 0.1. 0.1 divided by 2 will be 0.05, right? So now we are looking for the smallest possible value of the height. So you know that area of triangle is half times base times height, and we are looking for the height. So height is going to be area times 2 over base, right? So that means, let me write it down, 2 area over base. So we are looking for the smallest value of r, smallest h, right? Smallest h. To get the smallest value of right hand side, we need to have the maximum lower bound. This will be the 2 times then upper bound, no, low, we are looking lower bound of area over lower bound of base. Okay, so 2 times lower bound of area, you are going to subtract 12 minus 0.5. so here lower bound is going to be 12 minus 0.5 over lower bound of base is 5.75 minus 0.05, right? Yeah, so that's what you are going to calculate. This is 2 times okay, so I have already done this one. This comes out to be 4 point, let me just confirm it, 12.12 minus 0.5 d times 2 3 divided by 5.75 minus 0.05. yeah, this is 4.035. so this comes out to be 4.035, so approximately equals to 4. so we will write down as 4. okay, that's the lowest possible value. Now number 20, this is the last question of this paper, and this is a bit tricky and it is 6 marks question. So let's do that one. We have this cone here. The diagram shows a frustum of a cone. The frustum has base radius 0.6 and vertical height 0.48. The vertical height of the original cone is 1.44. Calculate the total surface area of the frustum. So let me make this again here. This is the frustum of this cone, like this. So this one here is small r, and this here is going to be from here to here is capital R. This is small r and capital R, and this one is the height of the frustum, and this is the slant height. Okay, so here I am taking the slant height of this, the from here to here, the cone, this part. Okay, this is the L that I have taken from there. Okay, so this is 1.44 and this is 1.48. From here it is 0.48. so if we take out this 1.44 minus 0.48, so is it 0.96. so this is from here to here, this one is 0.96, right? So this is 0.96. so this one is let me write down this as O and O dash. So this we don't know yet, so this is 0.6. so the total surface area of the frustum, so total surface area of the frustum, total surface area of frustum, we should have the area of this part here, the part that I have drawn, then plus the area of the okay, so yeah, so we will have the area of this this circular part and this circular part over here. So then that means we are going to do this way. So let me just first of all do this the triangular part here. So in triangle, let's say this is, let me just change the name here, this is P here, and if I take this as M, so avoid any confusions. So if this is M, right? So forget about this, let me just show you the other way. Okay, so now I will take here triangle APB, triangle APB and triangle AMC are similar, right? So this is the triangle here. You can see we have this triangle here, this one here, this is A, this I have taken here B, and this is C. Okay, so triangle APB and AMC. So these two triangles are similar, so we will be taking the part of the similar part. It is going to be 0.96 over 1.44 equals to r over 0.6. So from here we can find out r is 0.4. So we got this as 0.4. So this smaller part is 0.4 now, this r, right? So now in triangle, now we will take in triangle APB, we have L squared, small l square equals to AP squared plus PB squared. So this is L, we have the square root 0.96 squared plus 0.4 squared. So L comes out to be 1.04. We will need that L. Okay, so L is 1.4, this one is 1.04, right? So now AC, we are looking for AC, the whole thing. So AC squared, we use the Pythagoras theorem, 1.44 squared, 0.6 squared. So this is AC comes out from here is 1.56, right? So all these are in meters actually. So now we are looking for the total surface area. So for that I will take the curved surface area, area of the small. So you see we have two cones here. The top one here, I have divided it into now two parts. This one here, the top one from here to here, right? The other one, the big one here, until, bear with my diagrams. So we are talking about now this big one. So this is the big and this is the small cone. So if we subtract the area of big one from small, we will left with the area of this frustum here, right? Plus you have to add this area of the circular part, right? So area of the small cone, area of small cone, we know that area of the cone is pi RL. So it's pi, smaller area radius is 4 and L is 1.04. So this one we have taken the smaller one, right? So this is equal to 1.306 meter squared. Then area of the big cone. So the big cone is pi r and capital L, right? So this is pi into 0.6 and capital L was 1.56. Okay, so this is 2.940. So the total surface area now, total surface area of frustum, we are going to subtract 2.940 from the big one minus the smaller one, which is here 1.306, then plus area of the circle, small circle plus area of the big circle, like this. So this one is 1.634 plus pi into r 0.6 squared plus 0.4 squared. So just plug in all the values and we got here 3.268 meter squared, right? So that is the final answer. This is 3.268, right? So that's how you can do this question slowly. So what I have done, I have taken out the area of the bigger cone minus area of the smaller cone when you take it out, but still we are left with these circular parts here. So then we added two circular parts, right? And we have already calculated the required dimension, right? So thank you so much guys for watching. See you in the next video. Be blessed guys.